what I'd like to discuss now for just about an hour, maybe even less, is general troubleshooting, just basic video game troubleshooting. You get to the game, it ain't working, like this one's not working, you know, what the hell's wrong with it? And on page 67 on the bottom, you see a drawing of pretty much how a video game is put together. There's really not much to a video game at all. You know, you have an AC plug, power distribution. The AC power goes to the power supply. It also goes, actually I probably should draw it in. The AC power actually also goes to the monitor. It doesn't go directly to the monitor though. In every game, in every video game, the monitor is powered by something called a transformer. We're going to take a look at transformers right after we're done with this segment. And I'll tell you in great detail what they are. In this case, every video game is powered by a transformer like this. It's called an isolation transformer. It's a safety transformer. There's an article in your blue book about isolation transformers. Hopefully I'll point it out to you a little later on. In every single video game, the monitor is powered by the isolation transformer. Without the isolation transformer in it, the monitor will have 120 volts on the metal chassis of the monitor. Meaning that if you are grounded somehow and you touch the metal chassis, you shock the living daylights out of yourself, number one. Number two, if you actually ground the metal chassis of the monitor without the isolation transformer powering it, you just blow the snot out of it. You'll blow up the monitor, you run the risk of damaging the logic board, all kinds of stuff. So in every video game, there is an isolation transformer that's used strictly to power the monitor. And I'll just draw it as a box here, because we're going to look at it in just a little bit. Transformer, the term transformer is often abbreviated XFMR. We use the letter X as the prefix trans. I have no idea why that is, but for instance, transformer XFMR, transistor XSTR, transistor. Don't know why. And then there's of course my favorite holiday, Transmas, right? So anyway, so the isolation transformer, not something that never ever fails, really. The isolation transformer is then used to power the monitor. And of course, this is the 120 volts AC. The isolation transformer takes 120 volts AC in and gives you the exact same thing out, but it is isolated. It's a safety transformer. I mentioned it to you before. I'll cover it again in just a little bit. The power supply creates the DC output for the logic board, the printed circuit board, PCB, printed circuit board, logic board, computer board, whatever you want to call it. I mentioned it before, all computers require 5 volts DC to operate, and that's where it comes from. It comes from the power supply. And that's used to power the printed circuit board, you know, the computer board, and so on. So inputs to the computer board are the 5 volts DC that comes from the power supply. There's also 12 volts and -5, and we'll look at those later. Those are for the sound systems usually. Another input is the joystick, the buttons and stuff. That's an input to the logic board, obviously. Outputs from the logic board are the output that goes to the monitor that shows you the display on the screen. Obviously, the picture on the monitor must come from the computer board. That's what it's for. And there are actually 3 different colors, red, green, and blue. We'll talk about those in very great detail on Thursday. And of course, what's wrong with Shirley's Vigilante, there's only red, there's no green or blue. And the speaker is another output, obviously, from the printed circuit board. Well, let's say you get to the game and you know, here's a typical problem with a game. You plug the game in. In this particular game, it does nothing. In this particular instance, this game does absolutely nothing when I plug it in. When I plug in the main power cord here into the wall, no lights, the marquee light doesn't light up, it doesn't point up, it doesn't make any game sounds, it's completely dead. The first thing you want to do is to check the power cord. This is obviously pretty simple, and I'm sure that you've had this problem many times. And in this case, this is what's wrong with it. Number one, the ground pin is missing here, which is something that's usually doesn't cause major problems, but if the ground pin is missing, number one, you have a possible shock hazard between this game and another game. You've probably seen this on pinball machines. You touch two rails of adjacent pinball machines, wow, you get a little buzz off of that. If they're both properly grounded, that's impossible. Number two, most common thing is this is in the wall, the game gets pushed up against it, it whacks the thing, and the little blades here are loose. And that's what's wrong in this case. Now, here's what I do to troubleshoot it. If I have a choice of two different ways to troubleshoot something, with the power on or power off, I always do it with the power off. Here's what most people do to check this out. Most people will plug this into the wall, and with the meter set on 120 volts AC, they'll put their meter probes here and here with the meter set on AC and measure the voltage there. I mean, that's what most people do. You go, oh, well, there's no voltage there. That isn't how I do it, because there's a better way to do it with the power turned off with continuity. First of all, the first thing I did was this, and this is a really fast way that you can tell if the thing is hooked up or not. That is, if the cord is doing anything at all. I put my meter on the continuity beeper or on the ohm scale, whichever your meter happens to do, where it makes a beep, just for the sake of discussion. Makes a little beep. I put 1 meter lead on one of the prongs and 1 meter lead on the other prong. If the game is plugged in, and I mean not plugged in, but if all the switches are turned on and it's hooked up right, I should be seeing some resistance here, because I'll be reading across the winding of the transformer, which we'll talk about later on. I'll be reading across the input of the power supply, across the fluorescent light. There'll be some resistance there, and as you can see, my meter says open right now. There's nothing going on here. If I turn, make sure all the switches are on. Are they on or off? There's an interlock switch in the front door here. Is that pulled out to turn it on? There's one in the back door. Are all the switches on? Yeah, they sure are, but I don't have any reading on this meter whatsoever, so I've got a broken wire somewhere. Something's broken, blown fuse, broken wire, something. Next step then is, with this thing out, disconnect in my hand, not plugged into the wall, I use my meter on the ohms scale, the continuity scale, like the 200 ohm scale or the whatever beeps on your meter, and I start by putting 1 meter lead on one of the prongs and the other meter lead on one of the wires here, or I put 1 meter lead on a wire here and then just try each of the two prongs. What I'm checking for there is continuity. And in this case, what I have is when I put 1 meter lead here and 1 meter lead on this top prong, it beeps. That wire's good, but when I move to the other one I don't get a beep. One of the wires is broken, and it's really probably the plug. Although, this particular cord has this on it. This is completely illegal. This is completely dangerous. This is not acceptable, and it's just, you can see that it's spliced here or taped or something. I'm not sure what's underneath this. I'm kind of afraid to open it up. I guess we could take a second and just look inside here. Since it doesn't work anyway, we're not worried about it.
From the person I bought the game from, that's probably what it is.
It's probably an unsoldered splice.
Yeah, exactly. Or
something equally queer. Now, to be honest with you, sometimes you do have to extend the wires on games. And if you ever have to do that, if you gotta do it, you really have to change the whole power cord and put a longer power cord on it. Oh, look at that. It's not even, see what I tell you, not even soldered. Okay, that really sucks. Now let's say you get to the game and the screen is blank as it is here, completely blank. But the marquee light is on, meaning it's plugged in and everything else. This is the most common problem, and I see this all the time. When this happens, the first thing you want to do after you verify, yeah, it's plugged in and everything else, go down here and coin up the game. Go down to the coin door down here, drop a coin in, press the start button. Press the start button and listen for the game sounds. See if you hear all the game sounds. If you hear all the game sounds, that must mean that the computer's working, huh? If you hear all the game sounds, the computer's working. If the computer's working, the power supply's got to be working too, huh? Yeah. If the computer's doing its thing, the power supply's good. So right away, as soon as you coin it up and you hear all the game sounds, you know that the power supply is good, it's plugged in, the computer board is good. If you have a blank screen, but you hear all the game sounds, you have a monitor problem, don't you? I mean, right away, now you know you have a monitor problem. You don't mess around with anything else. You don't poke on the logic board. You don't have to even check the 5 volts. You don't have to do any of that. You just go ahead and fix the monitor. On the other hand, if I coin up the game and I do not hear any game sounds, I don't worry about the fact that I'm not seeing anything on the screen. I don't start working on the monitor. If I get to the game and I coin it up and I don't hear any game sounds whatsoever, the monitor isn't bad. You probably have a power supply failure. Your power supply is probably not putting out the 5 volts, and of course I'll tell you how to check that in just a second. The reason that the reason that the monitor isn't showing anything is that because the power supply is not powering the computer's not putting out those red, green, and blue signals that go to the monitor, and that's why you're not seeing anything on the screen. Wouldn't it be really stupid to rip the monitor out and start working on that when there's nothing wrong with it? So by coining, I know it seems so simple. You coin up the game, you press the start button. You'd be amazed how many people don't think to do that. I mean, it's such a simple thing. So if you get no game sounds at all, you probably have a power supply failure. If you get all the game sounds but no picture, it's probably a monitor failure. Computer failure will rarely cause a blank screen. When the computer fails, usually what you get on the screen is garbage. Jumbled bits of graphics, letters and numbers. You may see like blocks. You may see problems where you see the characters, but instead of being the image of the characters, you just have like squares that move around on the screen. Or it may be locked up, frozen. The image on the screen just, it may be completely locked up where you get to the game and the guy's... And that's it. You coin up the game, doesn't do anything. That's a typical kind of a computer problem. It is possible to have the computer fail and put out nothing at all on the screen, but it's not really very likely. So that when you get to the point where... let's say you coin up the game and you don't hear any game sounds whatsoever. The next thing you want to do is check the power supply. Check to see if you have your 5 volts. Now, certainly, if you just want to check the power supply to see if it's working or not, that's pretty simple. On the power supply, you've got the screws on the side. In fact, let me go over here and show you up close what I'm talking about here. When you look at the power supply, you have 2 screws down here that are labeled AC. This is obviously where the AC power comes in, the AC power that powers the power supply, 117 volts AC, 120 volts AC, whatever you want to call it. The next pin up is called frame ground. It says FG, frame ground is what that really means. This is AC power, frame ground. Not field ground, although some people call it that. It's actually frame ground. This is where the 3rd wire connects. This is where the 3rd pin, on your AC power, I discussed this with you before, the ground pin, the green wire, that's where that's supposed to go, on frame ground. If you don't put that on there, everything still works perfectly okay. That's primarily to keep interference from getting out of the power supply and into the rest of your video game. So that's pretty much okay there, even if you don't have it on there. The next pin up, labeled plus 5 volts at 15 amps. This one happens to be a 15 amp power supply. And then there's 2 ground connections there. There's another output that's minus 5 and another one that's plus 12. The minus 5 and plus 12 are primarily used for the audio circuits. For instance, the plus 12 usually only powers the audio amplifier. That's all it does. It just powers the audio amp. And the minus 5 is usually also for the sound generating circuits. Well, if you have a problem, and you suspect the power supply is bad. Question?
She had DC common on that.
Oh, DC common is the same as ground. Yeah, that's a good point. Why don't you hand that to me? If you have something interesting like this, point it out to everybody, because it's pretty interesting. There's another type of power supply made by a company called Hytron. It's actually a very excellent power supply. And here again you see AC. What they call ground is frame ground, the FG connection, same thing. Their regular ground they call DC common. See that? DC common is the same as ground is here. Ground down here is the same as FG here. You can see they're in the same position and everything. I know it's a bit confusing. It was just a matter of terminology. Can I hang on to this for just a sec? Thanks. Anywho, so you get to the game and you coin it up, it doesn't do anything. You've got to assume your power supply is crapped out. And the easiest thing to do is you put your meter lead on ground, the black meter lead on ground, the red meter lead on plus 5, and with the game turned on and powered up, you should read 5 volts DC there. If you don't have your 5 volts DC there, there's nothing coming out of the power supply. Well, we have a saying in electronics, and the saying is garbage in, garbage out. What garbage in, garbage out means is that when you get a bad output from something, garbage out, check the input. If the input's garbage, obviously the output's going to be garbage too. What I'm saying is, okay, you don't have 5 volts coming out here, check the AC input. Make sure you got your AC in. But if you have your AC input, which you probably will, to be honest with you, and you don't have any DC out, then the power supply is bad, of course, and that's how you determine that the power supply itself is bad. That's pretty simple, huh? Make sense? Now, one common problem that we have a lot is the 5-volt power supply just goes out of adjustment. After a period of months or years with temperature changes and changes in component values, the output voltage of the power supply may drop. It probably will drop. It's really important that that 5 volts be exactly perfect. The 5-volt power supply has to be exactly 5 volts plus 5 volts DC. It can only vary plus or minus a quarter of a volt, meaning that if it goes below 4.75, the computer will probably malfunction. If it goes above 5.25, same thing. Quite frankly, I find that almost nothing works properly at 4.75. Especially like Sky Shark here, it'll crap out at 5 volts even. We set, at Area Amusements, we set all of our games to 5.1 volts. We set the power supplies to 5.1. Some people say 5.17. Well, whatever. 5.1, 5.15, something like that. We just have found that we have far fewer problems that way. But where the heck are you going to check the voltage? Well, the logical place is the same place you checked it before. You go, well, I'll just put one meter lead here on ground and the other on plus 5 and adjust it to 5.1. Not even. Not even. And the reason why not is that by the time the power gets out of the power supply, by the time the current gets out of the power supply, through the wiring harness, through the connector, it's real easy to lose a few tenths of a volt. And since the voltage is so critical, it's very important that it's 5.1 volts on the logic board. The power supply is, of course, down here. It's way down there at the bottom. In fact, you can't even see it. It's down here. It's like down here. It's screwed with one whole screw. to the side wall of the game. There's your power supply right there. Okay, very nice, the mobile power supply. You know, it works. You know, this is a real typical kind of a shitty job, but we're going to fix it up, and it's going to be bitching by the time it leaves here. So by the time the current gets out of this power supply, through these wires, through this connector, which is not even very tight actually. Wow, it's pretty darn loose in fact. Through this connector and onto the logic board, it's real easy to lose a few tenths of a volt. So it's real important that we measure the voltage on the logic board. The JAMA connector is a standard kind of a harness that we use for just about for really all video games these days are the JAMA connector. And it's the same pinout for every game, meaning you can plug JAMA boards in from one game to another. And you can see that the first two pins on each side are ground. The next two pins on each side are for the plus 5 volts. Pins 5 and E are for the minus 5. The next two are for the plus 12. And then pin 7 and H is what we call the keyway. And that's a blank spot on the connector. If you look at the connector, you see this little white part right here. This is a keyway, and there's a slot in the board right here. Essentially, it keeps you from plugging this thing in upside down. It idiot-proofs the connector so that you don't run power into the wrong part of the connector. You may find that the minus 5 volts is unused in some games. It apparently is not used in this game because I have the ground wires, they're black. I have the red wires, that's for the plus 5. Then there's a blank spot right here. Pins 5 and E are not used. So this game doesn't use the minus 5. If you put minus 5, if you have a standard connector with minus 5 hooked up, and the board doesn't use it, that's okay. It's just not hooked up to anything. You can, on the board here, there's a little pin here, but it's just not used. And then the yellow wires for the plus 12. You'll notice that they've doubled up on the wires here. In fact, there's 4 ground wires and 4 plus 5 volt wires. That's because by the time the current gets out of the power supply to the board, you can lose some voltage there. The more wires you have, the less voltage you'll lose. Plus, if you just run one wire, you'll probably burn the pin on the board, and you'll burn the pin on the connector. We'll talk more about those pins in just a little bit. So they run multiple wires. Well, the important thing is to check the voltage on the logic board itself. I don't really give a rat's ass what it is at the power supply. I want to make sure that it's exactly 5 volts on the logic board. So where I check the voltage is here at the connector, on the JAMA harness. When the connector's on the connector here, when the connector that's on the wires is connected to the card edge, there's a little bit of the little plated finger sticking out from behind it. In the game, this thing is called, technically speaking, this is the edge connector. This is called the card edge. Card edge. Although people call this the edge connector too. Well, but if that's an edge connector and this is an edge connector, they're two different things. I mean, obviously, how can they both be the same thing? But if you call it edge connector, everybody knows what you're talking about. When I want to measure the 5 volt power supply, I measure it here at this connector. With the power turned on and the meter set on DC volts, I put one meter lead on ground and the other meter lead on plus 5, and with my meter connected to the board, adjust the voltage on the power supply. Now that kind of takes 3 hands to do it. There's a couple of ways around this. Number one, if you really like Chinese food as I do, and you can do this chopstick style, then you can use your meter leads like chopsticks and just go like this. Then you've got one hand free to adjust the power supply voltage. You can see a little bit of the metal sticking out. This is ground here. This is plus 5 here. So you can even use that little hole, or you can use this part right here. I put the red meter lead there. I put the black meter lead, up here on this one. And with my meter set there, and the power turned on and everything, I adjust the 5-volt power supply like that. So that's a good place to check the 5-volt power supply, because that way we're checking it on the board. And I adjust it so that it's exactly 5.1 volts on the board, and then I know that I've got my proper voltage. Yeah, Harold.
Can I ask you?
Howard, sorry. Yeah.
Okay. What would be the difference in using another ground path and checking putting your red lead on the...
Putting ground maybe here and checking...
So that you wouldn't have to...
You don't want to do that, because if you use this as a ground and just check the 5 volts here at the board, you're not checking this ground connection. In fact, I've screwed myself up that way. I've had a bad ground connection here. Using that as a ground, I checked it here, and I did have my 5 volts. But if I had gone right across from here to here, I would have seen that I didn't have my 5 volts. See, you're not checking that whole path that way. So when you're checking the power at the board, you really got to go right to the board. In fact, what I'm going to show you right now is an even better, more universal way to do this. Does this make sense so far, though? Yeah, Ken.
Is there any danger in adjusting that real fast too hard? You know, what if you just way up high real fast?
And you go way too high? Yeah, that's bad. Most power supplies are designed so that you cannot, even at maximum, go dangerously high. But I wouldn't trust a power supply at all. You never go, hey, let's see how, see how high it goes. With the meter connected, never adjust this without a meter connected, by the way.
Oh, yeah.
But with the meter connected, just slowly bring it up or down. I wouldn't mess around too much.
So it might be good to unplug it and do it, plug it in and see what you got.
You can't adjust it when it's unplugged.
I mean, I could unplug it off the board and do it and then put it on.
No, because, and that comes back to what Howard was mentioning earlier, and I'll amplify this tomorrow. In order to adequately test the power supply, it must have a load on it. You must be sucking current out of it.
Again, after I stick it back on and see how it is.
No, don't do that. Leave it all connected. Just adjust it with the power turned on. Yeah, Claude?
I know that it's the power supply that's giving the problem, because a little while ago, maybe 3 or 4 weeks ago, I had a serviceman come out there, and he said that it was having the same problem. The screen was garbage, and he said that the power supply had been almost turned totally off.
Ah, yeah.
He turned it back on, and it operated for a while, and now it's doing the same thing. So I guess the power supply is not...
Well, instead of speculating, as soon as we get an AC power cord on this sucker, we'll find out exactly what's going on. Yeah, well, I think we've got enough jazz here. Oh, look, see, Jeff is so well prepared. Look, it even has the lugs on it. Oh, sorry, Jeff. But you should never adjust a power supply without a meter hooked up. I went to this one location, and I'm watching this guy working on games, and he's down here messing around, and I see he's messing around with the power supply. He doesn't have a meter hooked up, and I'm going, hey, how you doing? Look, I fix video games. What are you doing there? I'm adjusting the power supply. Well, but you don't have a meter hooked up. How can you be doing that? Well, I just kind of turn until the game starts working okay, and then I'll leave it that way. Well, bullshit. Because it may work okay for a day or two, but you may be over-voltaging everything and blowing out chips eventually and so on. And speaking of chips, that's really the best place to check the 5-volt power supply. Checking it here on the JAMA connector is really cool. If you have a JAMA connector and you know that those pins are the pins, groovy. But this doesn't work for any pinball machines. They're not JAMA connectors. Doesn't work for redemption games. Doesn't work for older games either that aren't JAMA. So here's the way I really check the 5 volts. And what I'm about to show you now is really a handy bit of info to have. When you look at the integrated circuits on a logic board, they look like this. They're not quite this big, but they look kind of like this. You'll see a notch at one end of the integrated circuits. And or you will see a dot in one corner like that. And this denotes this as pin number 1, and the pins are numbered counterclockwise. So for instance, 1, 2, 3, 4, 5, 6, this would be pin 7, pin 8, 9, 10, 11, 12, 13, 14. Things you'll see, like there's the notch right here. That's pin number 1. There's a notch. That's pin number 1. Now this dot here, it's right in the center. That's just where they extrude the plastic into the mold. This is the notch that we're looking for here. See if I can find one with a dot on it. See the dot in the corner there?
Yeah.
Wherever it is. Anyway, you get the idea. Like that. So that's pin number 1. And the pins are numbered counterclockwise around the integrated circuit. Well, almost without let me back up. These integrated circuits, this package that the integrated circuits come in, is called a dual inline package, or DIP for short. Dual inline package. And they come in all kinds of different sizes. There's 14, there's 8-pin dips, there's 14-pin like this one, 16, 18-pin, 24, 60-pin dual inline packages. You know the little switches that we use in games to set the options, like the number of plays per coin and all that kind of stuff? Those guys are called dip switches. Mm-hmm. Let me find them. There they are right there. These little guys right here.
Right.
And these little switches, you can flip these switches up and down, and they set the number of plays per coin and stuff like that. These are called dip switches. They're called dip switches not because some dipstick invented them. They're called dip switches because they're in that same dual inline package, the dip, dual inline package. Well, on these dual inline packages, almost without exception, there are a couple, but almost without exception, this pin will be the plus 5 volts DC. It's what the hotshot technician types call VCC. I got no idea why it's called that, but in case somebody tells you that, say, oh, did you check your VCC? Yeah, it means check the 5 volts. And then kitty corner right across the chip on this other side right here, this is ground, which of course is 0 volts. When I want to check the 5 volt power supply on something, I don't usually go to the edge connector. What I usually do is go across a chip. I put the black lead on the ground pin, on that corner. I put the red lead here and measure the voltage like that. I only have to measure it across one chip. They're all hooked up together on the board. By doing it this way, number one, I can check it on anything. I don't have to know which connector is which. I don't have to know anything about how the power gets into it. Also, this works for anything. It works for pinball machines. It works for redemption games. It works for, everything. It works for everything. So that's what I do. Now, yeah, go ahead.
Basically, the power is always opposite the dot or opposite.
The 5 volts is always right above the notch. Holding the notch to your left, it's always right above there, or almost always. Now, specifically, there is one type of integrated circuit that I do look for. We have a family of integrated circuits that we use in games, and it's known as the 7400 series. It's called the 7400 series because the part numbers start with the number 74. For instance, 7404 or 7408 or 74161. You don't have to write these down. I'm just giving you some examples. 74245. It may say 74LS something or other. And the LS means that it's a low power, high speed chip. Actually stands for low power Schottky, named after a guy named Schottky that invented these high speed things. In any case, it's the 7400 series chips that almost without exception, there's only a couple of exceptions, have this corner as the plus 5 and this one is ground. And so that's what I look for. In fact, let's take a look at those. Let's see if I can do this upside down again here. If you look at these parts, you'll see that many of them start with the number 74. Here's SN74LS175, made by Motorola. Here's another Motorola chip. It's a 74LS32. Let's go over here. Oh, they're all Motorola's. How about that? Here's a Texas Instruments chip. SN74S74. That's a high-speed chip. And so on. These are the guys. Here's one that says M74LS374. Mitsubishi, exactly. You can see the Mitsubishi logo. You'll see this a lot. Many times you will see a 2-letter prefix on the beginning of these things. 1 or 2 letters. It may say SN, it may say MC, it may say M, TI, something like that. Whenever you see a 2-letter prefix on an integrated circuit, you can ignore that, baby. It has nothing to do with the part number. That will change depending on who makes the chip, whether it's made by Texas Instruments or Signetics or Motorola or anybody. What we're looking for is the first 2 numbers. And if it's a 7400 series, those are the ones I'm looking for. And with the power turned on, I just go right across those chips. Now, when you do this, really important, it's very easy to slip with your meter lead. It's a little more convenient. So, you want to be careful because the power is turned on now. When you put your meter probe on this thing, don't try to put your meter probe right here on the top of the pin because, bam, you can slip and short these two together. Put it here instead, in between the pin and the body of the chip, like that. See how I'm pressing on this? I'm not even looking at it now, and I'm holding it on there. I could never do that if I tried to put it just right on top of the pin. I'd have to be very careful to not short the two together and slip. So by putting it in the corner like that, you can jam it up in the corner, and it won't slip off. So make sure you do that because the power is turned on. The power's turned on, and if you try to put the meter probe right, on the top of the pin, you'll slip and short the two together. If you short 2 pins together, it probably will not damage anything, to be honest with you. It really probably will not damage anything. These types of integrated circuits are pretty forgiving when it comes to short circuits, but you may damage something, so why take the risk? So instead, I put the positive, the red lead here, the black lead right here in the corners, just jam them in the corners, and with my meter there, I set the power supply to exactly 5.1 volts on the board. I don't care if it's 5.1 or 5.2, I should say, or 5.3 at the power supply. I want it to be 5.1 on the board itself. Does that make sense? That's really important. This is the #1 cause of people sending their boards into the distributor for repair when there's not really anything wrong with them. What happens is someone gets to the game and let's say the game's doing some kind of wacky things like shutting off intermittently. You get this complaint, the location says, yeah, the game just froze up or whatever. They turn it off, you get there, you turn it on, of course it works perfectly okay for you. Or weird bits of graphics and weird jazz on the screen, all this kind of stuff. This may just simply be a power supply problem. And what happens is people measure the voltage down here at the power supply itself, down here on the inside, set it to exactly 5 volts. By the time the current gets up here, through this wire, and over here to the logic board, maybe it's only 4.9 volts on the board. SkyShark's a perfect example of it. This game doesn't even work well at 5 volts. 5.1, perfect. But like I've had them at 4.95, and they freeze up, they shut down, all kinds of weird things happen. So I always set it to 5.1 volts on the board. These integrated circuits that we use in games, these 7400 series, belong to a family of integrated circuits known as TTL. We're going to talk more about TTL in just a little bit. TTL stands for transistor logic. And all these 7400 series are these what we call TTL chips. It's called TTL because essentially it was an outgrowth of some other families of integrated circuits. They started out with resistor transistor logic. They called it RTL. Didn't work with beans. Then they came up with something called DTL, diode transistor logic. Didn't work with beans. Then they invented this stuff called TTL, and TTL works great. TTL, all the stuff, almost every game, almost every integrated circuit in every game we work on is what we call a TTL chip. It works really great. It's almost indestructible. It's easy to design with. It's easy to work with, and in fact, there's all kinds of things that you can do with TTL, messing around with it. It's pretty forgiving. In fact, I'm going to show you shortly a little trick that will enable you to find bad integrated circuits on things without even knowing how they work. I'll show you that in just a little bit. Transistor logic. TTL, transistor logic. So setting the 5 volts is really important. If your game is doing all kinds of wacky things, let's say your game is doing all kinds of wacky things like weird graphics on the screen, bits of garbage, it's freezing up, stuff like that, and you've tested the 5 volts on the board and adjusted it and it's perfect, and you still have a problem, you have a board failure. There's something wrong with your board. Don't give up. There's plenty of things that you can do, and I'll show you in just a second. I do want to mention one very important thing about this edge connector, though. Before you adjust the power supply, make absolutely certain that the edge connector is clean. Make certain that the connector on the board, the card edge, is clean. That's one of the places where you lose a lot of the voltage, is in the connection between the connector and the card edge. If that's dirty at all, it's real easy to lose 1/10 or 2 of a volt. You don't want to adjust the power supply until you've improved this. So before you adjust the power supply, I do this all the time. At the very least, with the power turned off, because you never plug in anything or unplug it with the power on, other than the AC power cord, obviously, you might try plugging and unplugging this a couple of times. That's something you should always do anyway, because just the process of plugging and unplugging it cleans it off and makes a better connection. But it's best to clean this connector off, this card edge off, with a pencil eraser or even a dollar bill. Just take a folded up dollar bill and rub it against the connector, and it cleans it right off. That's pretty important because you don't want to have any dirt at all on the connector. If you can move the connector like this and the game freaks out and goes on and off, if you like move the connector back and forth, the game freaks out, you probably have some bad pins on the connector. Like this one just doesn't hold on worth shit. Part of that is the terrible way that this was mounted in here. Too tight. Just too tight. But there's another little tool that I always carry with me. It's called a pin extractor tool. It's just a little piece of steel. Real thin. Almost, yeah. In fact, you can make one out of like a thick brass switchblade from a pinball machine. Here's what this is for. Eventually, these pins do go bad. These pins on the connector here, eventually those things will go bad. Especially if you've got a JAMA game that you've converted 12 times already. And the power pins usually are what goes bad. If you can wiggle this connector and the thing goes on and off, you got some problems with the pins. It's real easy to extract these pins. Not so easy with one hand, but let me just do it here. You insert the tool in this little slot right here, and then you can pull the wire out. Hopefully I can do this with one hand. I don't know if I can or not. Like that. You just pull the wire straight out. And here's the pin. What you've done with the pin tool is push this little barb in. You see this little barb right here? This little teeny barb that's sticking up? What you've done with that pin tool is depress that so that you can then pull it out this way. It's like a fish hook, basically. What happens on these pins is they get smashed, like this one is. It's quite flattened. This is supposed to be out much, kind of a bit fatter than this. And you can buy these pins, you can replace the pins. I'll show you in your book, there's a source for these kind of connectors. What I often do in the field though is this. I simply take my little tool and pull it out and just kind of stretch it out, yeah. Pencil eraser. Yeah, see how I made it stick out more here, like this? Okay. Then when you... This was really cool. This is a typical kind of a thing that comes into the shop. First of all, the power cord was bad, so I cheesed a little temporary power cord on there, and it's working. So then we got the marquee up. No coin, the screen was blank. I coined it up, no game sounds whatsoever. We go over here to the connector, 3.7 volts. Not enough, obviously. With the meter connected here on the connector, adjusted up the power supply. I don't know whether it was someone was messing with it or what, but it was way down too low. Cranked it up to 5.1 volts. Fired right up. Came up. The test does a little self-test dance that it does, checking its internal stuff. Fired right up. Just to verify, Claude checked it across this chip right here, 5.09 at this point. Fine. Works great. This monitor does have a problem. And we'll talk about it Thursday. It's real bright on one side and real dark on the other. It has a typical capacitor failure. It happens to be capacitor C702. And I know, like I said, I'm not a genius. I see this 100 times. I've changed C702 in 100 different monitors. And because I do these monitor labs on the road all the time, I see tons and tons of monitors. It's almost all I work on, really. I work on monitors in the field. I mean on the road when I'm here doing the classes. And when I get home, most of my repair work is monitors. Because the other people can do the simple jazz, and the monitors, they just don't know. So I've changed this cap a ton of times. By the time we're done with this game, it's going to look really bitchin'. First of all, it's not going to have this dirt on it. This is, I don't know if it was on location like this, but this is completely unacceptable. Yeah. Dirt is really... Oh, thanks. God, you're prepared for everything. There you go. Dirt's really unacceptable as far as player appeal is concerned. It's just a clean game is so much better than a dirty game. Anyway, so now it's up, it's working, we got our game up and everything else. We just have to kind of fix the monitor and tweak a little bit, and it should be fine. And of course, I think we want to remount that power supply properly and all that kind of stuff. You see all the garbage on the screen. Now, this can be caused by a bad power supply. Disregard that flashing bar. Like I said, that's just a difference in the scan rate between this game and the camera. But you see where it says Sky Shark, it's doing all kinds of weird stuff. And all that weird stuff. And probably the game would play, actually, if I coin it up. Let's see what it does. No sound? Oh, I turned the volume down. Now, the little plane is up there. I can move it. I can fire bombs and stuff like that. It plays. I've seen games on location like this. Anyway, this is what... Haven't you? Sure you have. Okay, so this is what I'm referring to. When I refer to garbage on the screen, this is the kind of thing that I'm talking about. Naturally, you always want to eliminate your power supply as a cause of this problem. You want to make sure that you adjust the 5 volts so that all that is perfect before you do anything to the board. And as a matter of fact, and this is pretty important, so try to remember this, sometimes you'll have a weird power supply problem where the 5 volts really does seem perfectly okay. When you measure it with your meter, it's 5.1 or whatever. But you have, I guess the best way to describe it is as a hidden power supply problem that your meter cannot locate for you. Sometimes power supplies put out a huge amount of electrical noise that your meter just doesn't see. An oscilloscope would see it, but your meter doesn't. When you have weird problems on the board like the one I just showed you, despite the fact that you might measure the 5 volts and it might be perfect on the board, it's not a bad idea to take 10 minutes and throw in a new power supply first. Now, I got to admit that I don't do this. I really don't, because most of the time when you have problems like this and the 5 volt test's okay, it is the board that's bad. But sometimes it's the power supply and you can't figure it out. And since there are only a few screws on the power supply, you don't even have to mount it. It's not a bad idea to take another power supply, just move all the wires over from one to the other, try the new power supply first. But if everything's okay, your 5 volts is okay, your connector's good, and maybe even you've tried another power supply and you still have the problem that I just showed you, you have a board failure. Don't give up. There's plenty of things that you can do to try to fix this problem. And one of them is this. The chips that are on the board very often simply get loose. I'm going to just unplug this so I don't do anything stupid. Very often, the only thing you have to do is push in on the chips. And sometimes you'll hear them going crack, crack as they snap in place. Some of these integrated circuits are in sockets. Some of these integrated circuits are in sockets, and it's real easy to tell which ones are in sockets. Excuse me, I'm just queuing this up for the folks at home here. For instance, these ones here are all in sockets, and you can see the socket down below here. This is the socket, as opposed to one that is soldered in place. Clearly, this is soldered right to the board. Clearly, this one is not. You see how it goes into this socket? And they stick up further from the board, too. You can tell because the ones that are in sockets, see how much taller it is? I mean, it's sticking up from the board. So, anyway, these guys work their way loose sometimes. Very often, all you have to do is just press in on the chips, your problem goes away. If that doesn't work, you need to remove and replace the chips. And here's how you do it. Really carefully, and I mean carefully, with a screwdriver. Put the screwdriver underneath here and carefully pry up the integrated circuit. Now, I am not prying it like this. I'm not going like, you know, like a crowbar. I'm not prying it up like this. I'm twisting it so that the flat blade of the screwdriver pokes the chip up. Do it from one side, and then go to the other side. Carefully prying it up. Never, under any circumstances, try to pull one of these chips out with your hand without a screwdriver, because you'll get one end loose, it'll go up like this, you'll bend the little pins, and maybe if you're lucky you can bend them back once. But if you break a pin off, these integrated circuits are custom integrated circuits. They're called ROMs, read-only memory. They contain the program information. They contain the rules of the game, how the computer makes the game appear on the screen, the images, all kinds of stuff. And I don't know which ROM contains what. It depends on the game. Probably the one that I pulled out contains some kind of image information, because that's the only thing that's screwed up, huh? The game was still working perfectly, just the images were messed up. When you get the chip out, look at the pins. Are they clean and shiny as these ones are? No problem here. But if you see nicotine and dirt and stuff like that on them, like this pin right here on the corner, maybe, see a little bit of, well, you can see a little bit of dirt on them. Okay? Take a pencil eraser, carefully clean them off. When you do that, rub with the pencil only in this direction. Don't rub straight across the pins because you'll bend them. Rub only, you know, down like this. What I usually do is put the chip on something like this, and then using the pencil eraser, rub the pencil eraser that direction to clean off all the pins. When you go to put this thing back in, be observant. They fit both ways. They fit this way and they fit this way. They only work one way. The other direction they blow up. So if you'll notice, they don't really blow up, but they fail. You'll notice that all the notches are pointing the same direction. See, notch, notch, notch. Buenos notches? Those notches there. All right? All going the same direction. When you go to put this guy in, you got to be very, very careful that you don't bend a pin. If you've never done this before, if you've never pulled a chip out before, in fact, I'm not going to even try to do it with one hand. I'm going to put this aside for just a sec. If you've never done this before, if you've never pulled a chip out before, don't even try this on a board you ever expect to work ever again in your life. Try this on a junk board. It's so easy to bend those pins, isn't it? I mean, it's unbelievably easy to bend a pin. If you break it off, you're really doomed. You'll have to go to your distributor for a replacement part, and it'll be 60 or 80 bucks. Yeah, it'd be really expensive for a custom chip like that. So, be really careful when you do it. Let me just put this chip back in here. So, make sure the notch is going the right direction. What I usually do is put in one side part way, put in the other side. Gee whiz, are they all lined up? Yeah, I hope so. Well, it's not my game anyway, so it's not that big a deal, but
Yeah.
there we go. And let me just put the integrated circuit back in that I pulled out that actually caused the failure. If you know, you can switch them. It's funny, if you switch them, you won't damage anything, but you see some very funny things on the screen. I've done it before where you switch the character, it's called the character ROM, the thing that makes the images. Like, for instance, you switch the ROM for the guy's head with the guy's feet, and he ends up, as he turns his head to look around, his feet, it looks like feet moving different ways, and he's got his head down below. There's all kinds of weird things you can do. I don't suggest you do it. Anyway, so one at a time, you pull out the integrated circuits carefully, prying them out with a screwdriver, put them all back in. It'll take a little bit of time, but for instance, on pole position, which we operate a lot of pole positions, I have to do this about every year, pull all the chips out, put them all back together again. And that solves a lot of board problems. About 20-30% of my board failures, that's all I do. So again, you get to the game, it's got this weird junk on the screen. First you check the power supply, because that's the most likely cause of that problem. But if all the power is all okay, you definitely have a board failure. Don't give up. First thing, try pushing, turn the power off, push on all the chips. Turn the power back on. Does it work? No. Carefully pull each chip out one at a time that's in a socket. Clean off the pins as necessary. Put them back in, fire it back up, see what you have. That really solves a lot of problems. I never send a board away without doing that first. Now, just because that doesn't work, or if that doesn't work, you do not have to give up. There's still another thing that you can do. Those big chips, those ROMs, these ROMs down here, I find lots of failures in those things. They're special custom integrated circuits, and they're actually programmed. They come blank to the manufacturer of the game, and the manufacturer of the game programs them in with certain information, and sometimes the programming bombs out somehow. I don't know why, heat or whatever, it just fails. When many games have a self-test in them. You've probably seen it. You fire up a game, it says ROM okay, RAM check, or whatever. If it tells you that one of those devices, one of those ROMs or something that's in a socket is bad, it may be that, or it may be some other chip, but you certainly want to try that first. Another thing that you can do is to get another one of the same game and try swapping all the chips that are in sockets. I always tell my boss, never get just one of anything. Never get one of any game. Because if you only have one, I can't do that anymore. But for instance, we had an outrun problem. And we just saw garbage on the screen, like this garbage, almost exactly the same. But it did pass the whole ROM check. I don't know how or why, but it did. So I took the bad boards and I drove 20 miles over to a location where we had another outrun, and I sat down on my ass behind the outrun, and one at a time I took the integrated circuits from the bad board and swapped them with the good working board. You should always do this. Try the suspected bad parts in your good working test bed. The reason you do this is that you may have more than one bad integrated circuit on your bad board. This way, when you move it over, you can tell, oh, I moved this chip over, now the problem's in my new working game, my working game. Obviously, that chip that I moved over is bad. So you don't have to know anything about electronics to do that, do you? You just have to start swapping the chips. Make sure you swap the correct one. You know, have the exact same board, swap them one for one. And if you find that you have a bad part, then you can call up your distributor, and you have to get these from your distributor. And order the replacement ROM or replacement part, whatever it is. I've fixed tons of boards that way. Tons of boards. And again, that doesn't take any intelligence at all. You just have to sit down and do it. You can't be in a hurry. If you're swapping chips, you cannot be in a hurry. If you've got 12 service calls and the boss expects you to do this in a half an hour, it ain't going to happen. You're just going to make mistakes. You're going to bend something. You're going to break something. Don't do that. It takes a lot of time. Does that make sense so far? Okay, so that's another thing you can do, yeah.
If those ROMs cost so much to replace,
Yeah.
how do you validate or how do you justify whether
The game is worth it or not?
Yeah.
That's a very subjective decision, isn't it? That's where your experience as an experienced operator comes in, I guess. You know, would I spend 70 or 100 bucks on Sky Shark? Sure, I would, no question about it. Would I spend $5 on Vigilante? Nope. I wouldn't spend a penny on Vigilante. No offense. I mean, you're not planning on operating it, right? It doesn't make any money whatsoever. Vigilante is a spare parts board. Vigilante is a good board to practice on, pulling chips out, soldering, unsoldering. That's what you use Vigilante for. If you don't have any junk boards, you can probably pick one up for nothing from a distributor or another operator. Jeff's probably got a million of them. No, he operates that crap. Oh, no, you do you? Oh, yeah. All right. Anyway. Another problem that happens on boards that you can fix real easily is a problem where the game works perfectly okay when it's cold, but when it warms up, it fails. We've all had these kind of problems. Or it works perfectly okay when it's warm, but it doesn't work when you first plug it in, or something like that. These are thermally intermittent problems, and these are real easy to find. Thanks to Jeff bringing this in. And let's see if this is Freon anymore. Hopefully it's not. Here's CFC Impact 0 CFCs. It's got HCFCs, whatever they are. All right. Well, anyway. No, it's carbonated hydrochlorine. I don't know, anyway. Used to be dichloromethane, a.k.a. Freon. Anyway, what this is it's called Freeze Mist. This one's called Freeze It. Component chiller, circuit cooler, penguin hemorrhoid spray, I don't know what you call it. It's some kind of freezing thing. And here's what this is for. When you have a problem with a board where it is thermally intermittent, that is, when it's cold it works okay, but when it's hot it doesn't, you use this can of freeze spray. And what you do is this. First thing you do is you have to heat the board up so that you actually have the failure. You have to actually have the failure, obviously, first before you do this. There's several ways to do that. One way is to close the game up, tape up all the vent holes, wait till it fails. Another way is to do that but throw a light bulb inside. You know, regular, like a 100-watt light bulb. Best way is the hair dryer. Steal your old lady's hair dryer. Hair dryer, clean it all up heat it all up with the hair dryer until the failure occurs. Then, one at a time, one at a time you start freezing the chips. I always start with the big ICs. And you just drill, don't go like this. Just drill a little bit on it. When you get to the bad IC, the problem will go away. In other words, you hit the integrated circuit, you start hitting them one at a time. Let's see if you've got the garbage on the screen. Only occurs when it's warm. You hit it up, you freeze the chip, bingo, problem goes away. Now, you may have found the right IC, you may have not found the right IC. Heat it up again with the hair dryer. Temperature cycle it many times. What I often do is I'll cover up the adjacent chips with my fingers like this, barely hit it. While you're up here, if you've got a wart or something, just go ahead and freeze that baby right off. Just hit it. Okay, problem goes away. Get the hair dryer out. Heat it up. Oh, problem occurs. Make sure that you are just hitting that one chip that you think is bad. Temperature cycle it 5 times to make sure that that's the chip, because it's really easy to overspray and hit an adjacent chip and cool that one off simultaneously. Once you've located the chip, of course, this doesn't fix it. It only locates it for you. You know which chip is bad, same deal, then you order another chip. I have never failed to find a thermally intermittent problem with freeze mist. Never. You can, and I've gone through a couple of cans of it sometimes. Sometimes it's, it's always, of course, the last chip you hit. But I've gone through a couple of cans of it. You can get at any electronics store. And it works great, not only for things like this, but in a monitor if you have a thermally intermittent problem, and anything that works when it's cold but fails when it gets hot can be found by freezing it. So that's a really cool method that works great, and I've fixed tons and tons of boards this way. Like I said, I've never failed to fix a thermally intermittent problem with freeze mist. Always been able to find it. Yeah, Susan?
What about the opposite? It doesn't work when it's cold.
Well, same thing. It doesn't work when it's cold. Same thing will happen. You'll heat it up. It'll be working. When you hit it with the freeze mist, it'll stop working. Same thing, isn't it? Only opposite. So, whatever that means. Okay, so that's another really cool thing that you can do. Any questions about that so far? All right. Finally, one more excellent thing. What I'm going to show you now will just blow your mind. Turn to page 27. No, sorry, 25. 25. What I'm about to show you is something that I'll discuss again when we talk about pinball machines. But what I'm about to show you is a little trick that will enable you to find bad integrated circuits on logic boards without even knowing what the hell you're doing. And it's based on the fact that these integrated circuits are TTL, transistor-transistor logic. They're made of transistors inside. Remember when we tested the transistor, we were looking for that junction drop thing. Remember the junction drop, right? Well, there's a common problem with all kinds of systems, really, not just video games, but especially in video games where you'll blow one of the input chips. Here's what happens. In a video game, you have the logic board, as you see in the drawing on that page. And the logic board is connected to the switches which are in the control panel of the game. You know, all the switches that are in the control panel. And those switches are what we call normally open switches, abbreviated NO, normally open. Meaning that when you're not pressing the button, the switch is not connected, right? It's open. What that means is that we've got quite a long wire from the logic board up to the control panel. If you look at the game, from here, the wire goes all the way down here, all the way down here, way up and up underneath, you know, and up to the control panel. So the wire is actually, you know, probably a meter long, probably the wire of the control panel. And it is unterminated. That is, it's sitting there just in the air, basically. It acts like an antenna, is what happens. It acts like a big, long antenna. When you come along, rub your feet on the carpet, and hit the game with static electricity, that static electricity can be 20 or 30,000 volts, believe it or not. When you zap someone with static electricity, it's a lot of voltage there, many thousands of volts. Remember that these integrated circuits are only 5-volt systems. It's very easy for that lightning bolt, that static, to be picked up by this wire and couple even 10 or 15 or 20 volts into the input of the integrated circuit. Obviously, since the logic board is made of nothing but integrated circuits, that wire goes into an integrated circuit somewhere on the board, and it blows the chip. What it does, though, fortunately in a way, is that the inputs almost always short circuit. Let's say that this goes to a switch somewhere like this. Inside this thing, there's a transistor. Inside this chip, there's a mess of transistors, thousands of them, really. And what happens is this input will short to ground. The symptom that you get is this. Maybe you've seen this. You coin up the game, and you press the start button, and the guy starts to move right by himself, or left, or up, or down. And so you go, well, that's easy. It's a joystick problem, right? So you open up the control panel, you examine the switch for move right, looks perfect. You meter it meters perfect. You take the wire off, let the wire hang in the air, you try coining it up, it still moves right by himself, with the wire hanging off. So you hold the wires this far apart thinking that the air is conducting or something like that. You don't know what's going on, still does it. You have a board failure. You have an input failure. Very common problem. And you can find that with your meter. Here's how you do it. Really a neat little trick. Since these integrated circuits are made of transistors, we can find this problem with our meter set on the diode test setting. Now here's what's weird about this particular failure. This particular test. In this particular test, you are going to ground the red meter lead. This is what's weird about this. You're going to ground the red meter lead. So you need to find a ground somewhere. Well, we know that that corner pin of the integrated circuit is ground, right? And if I ground it on one IC, I'm grounded everywhere. Or I could put it over here on this ground. It doesn't matter. Just get it on ground somehow. When you probe the pins of the integrated circuit, you see a junction drop. Like now the meter says 0.5. 0.5. No matter where I go, I'm going all over the place, and I don't even know what these pins do. 0.5. I've got no idea what these pins really do. 0.6. Do you see how they're all checking like transistors? When you get to the bad one, you're going to see something a whole lot lower. Maybe something like that. Or, well, here, let me see if I can find a better one here. That's dead short. It wouldn't be that bad. What am I doing wrong? Oh. Like this. You see it says like 0.17 is what the meter's saying right now. I'm having a little trouble holding it on there. That's much lower than 0.5, obviously. And you may see something like 0.05, or it may say, dead short or whatever. When you get to the bad integrated circuit, that pin will be much lower than all the other pins. Well, this is an unbelievably neat trick, and you can find the pin, by the way, simply by, if you don't have the schematic, which you probably don't, simply by following the trace back from the edge of the board, follow it back, and go right to the pin of the IC. Regardless of that, in fact, you can check them really fast. You don't even have to be very careful about it, since the power is off now. There's no power on right now at all. You don't even have to have the game hooked up. Here's the board. It's sitting on my bench, let's say. Ground the red meter lead, and you can actually do this. Just drag it across the pins. I'm not even looking at the IC. I'm just looking at the meter. I'm just dragging my meter lead right across the pins. Now, naturally, the ground pin will show you 0, because you're on ground on the other side. The power pin, the +5V pin, will also show you something very low. That's not what we're talking about. We're talking about all the other pins, the ones you check. And I can almost guarantee you that you will find the bad IC this way. It works really well. This particular method of finding bad ICs like this works so well that I have virtually abandoned my conventional troubleshooting techniques. That is, what most of the hotshots will do when they have a problem like this is they'll sit down with the oscilloscope, they'll power it up, and they'll start probing around all the pins of the ICs, which requires that you know how the IC works and everything. And you have to know what's going in, what's coming out, and all that stuff. I don't even do that anymore. When I have a board problem, and especially if it's an input failure or an output failure, this is what I do instead. Put the meter on diode test, ground the red lead, use my black lead to probe the pins of the IC. And this article tells you step by step how to do all of that stuff. In fact, not only does it tell you how to do everything I just showed you, but if you turn to the next page, it shows you how to change the integrated circuit as well. Because to change the integrated circuit, an integrated circuit that's... Don't you have this?
Yeah, I have it.
Oh, okay. To change the integrated circuit, we're on page 26 now. To change the integrated circuit, you're actually going to cut the integrated circuit off the board. Your main criteria when you change an IC is not to damage the board. That's the important thing. You don't want to damage the board. It's really easy to damage the board. You've already determined that the IC is bad. So you cut the IC off. You cut all the legs off the IC. In other words, you cut the body of the IC off, just leaving the legs, as you see in figure 4, sticking out. Then one at a time, you use your soldering iron to lift the pins off the board one at a time. You pull the pins off one at a time, then you use your solder sucker to suck the solder out of the holes, stick the new chip in, and away you go. Again, never do this ever on a board you ever expect to work again in your life the first time you do this. I must caution you, you must practice changing chips on a junk board. The first chip I ever changed took me 8 hours. And I ruined this poor Atari Space Race board. I had to put jumper wires all over the place. And it was really terrible. Now, when I change a chip, it only takes 5 minutes, and you cannot tell that I've changed it. It looks perfect. Again, it's just a matter of practice. Soldering, especially changing chips, is a skill that takes a long time to develop. You really gotta sit down and try this. But by pulling out the pins one at a time, it makes your job a lot easier.